We remind ourselves that isomers are defined as different compounds that have the same chemical formula. Isomers are different than resonance structures. In isomers, atoms are actually in different locations in three-dimensional space. We'll find that in some cases, isomers can have widely different properties due to the location of the atoms. In resonance structures, we have Lewis structures for the same compound where the atoms stay put and only electron pairs move around. The simplest type of isomers is called constitutional isomers. The atoms are simply connected in a different order. As an example, we have two different isomers of C4H10. The first one is sometimes called a straight-chained hydrocarbon, whereas the second is sometimes called a branched hydrocarbon. They both have 4 carbon atoms and 10 hydrogen atoms, but are in fact different compounds. The boiling point of the straight-chained isomer is -1 degree C, while the boiling point of the branched compound is -12 degrees C. Another example of constitutional isomers is two compounds both with the formula C2H6O. The first compound is dimethyl ether, the second is ethanol. Notice in the first, reading left to right, the chain has carbon, oxygen, carbon. In the second, it is carbon, carbon, oxygen. In this example, the physical properties vary widely. Dimethyl ether has a boiling point of -23 degrees C, whereas ethanol's boiling point is +78 degrees C. Why do the two vary so widely? We should recognize that ethanol can participate in hydrogen bonding, whereas dimethyl ether cannot. Finally, let's look at C4H8. We have a 4-carbon chain with 1 double bond. It's tempting to simply call these resonance structures because it appears that the carbons are not moving and we're simply moving a pair of electrons. But if we include the hydrogen atoms into the picture, it's clear that a hydrogen atom has moved from the 3rd carbon in the chain to the 1st. Instead of 2 hydrogens on each of those carbons, it's 3 and 1. These are two different isomers of butene. The first one is called 1-butene, since, counting from left to right, the double bond begins at carbon number 1. In 2-butene, the double bond begins at carbon number 2. There is no 3-butene, since that would be the same as 1-butene simply flipped around. These compounds have slightly different boiling points at -6 and +1 degrees C. It turns out that these are not the only two isomers of butene. We'll explore that further in the next section.